Hi students, I welcome you all for control system lectures. In the previous class, we have discussed a numerical problem on Nyquist stability criteria. In that problem, open loop gain k is given and it was asked us to estimate the system stability for the range of k. Okay, today's problem will be a little bit different from yesterday's problem. It was given two poles at the origin and one zero, extra zero compared to yesterday's problem. Okay, so let us start this problem. So if you observe the transfer function, there are two poles at the origin. So first step to be considered is to draw S-plane, contour on the S-plane, which should eliminate this two poles part and consider whole right half of S-plane, right? So consider S-plane, okay, j omega axis and psi. We have to consider two poles at the origin. Okay, I am writing here itself two poles at the origin, and what we need to do is we have to consider whole right half of S-plane, whole right half of S-plane, except that particular part, right? Except this part, we have to consider whole right half of S-plane. Okay, so it tends to infinity. Radius will be tending to infinity. So if you observe, when omega will be 0, this is actually origin point just above the origin point. Here we can consider this as a 0 plus. Okay, omega is equal to 0 plus and omega will be infinity. This here, infinity plus infinity, and this will tend to go this direction, clockwise direction, and omega will be at minus infinity here, and this part will be omega is equal to 0 minus. Okay, so as the previous problem we considered the four cases, so similarly in this problem also we'll be considering four cases here. So this is C1, this will be C2, and here from minus infinity to 0 minus will be C3, and this particular part 0 minus to 0 plus. Okay, this will be C4. Okay, so what we need to do is we need to estimate g of s h of s plane, I mean g of s h of s axis. Mapping we need to do for this. We need to map this whole thing into g of s h of s plane. Right, JV, and this will be U. Okay, so while mapping S plane to G of S H of S plane, what we need to do is initially we'll consider case 1, C1, where omega will be varying from 0 plus to infinity. Okay, so let us start mapping of section C1. Case 1, mapping of section C1, right? So C will vary from 0 to infinity plus infinity. Okay, so first step is consider s equal to j omega, substitute s equal to j omega the given transfer function. Okay, this is the transfer function, just put s equal to j omega in that, and we need to segregate real magnitude and the phase by converting this transfer function into polar form. Okay, let us consider s equal to j omega. Well, substituting s equal to j omega, g of j omega into h of j omega will be 1 plus 4 into j omega divided by j omega into 1 plus j omega into 1 plus 2 j omega. Okay, so let us consider this as equation 2, and from this equation 2 what we need to do is we need to convert this particular form of transfer function into polar form. Okay, convert into polar form. convert equation 2 into polar form. So g of j omega into h of j omega will be root of numerator what we have is 1 and 4. So magnitude part 1 square plus 4 square into omega, right? So 1 plus 4 square means 16 omega square divided by, we have omega alone here, so that is nothing but omega square, and 1 and j omega is there, root of so this will be in the root, right? So root of this will be in the root 1 plus omega square into 1 plus 4 omega square. 2 is there, 2 square is 4. So this is magnitude, and phase will be here. Phase we have to consider for uh, all the roots. So how many roots are there here? Actually square, right? This is square actually, j omega square. Okay, then I think if it is j omega square, this root will get cancelled out. I think this root won't come here because there is a square here. Omega into omega, omega square will be there, right? So phase, if you see, there is omega square, each omega will contribute minus 90 degrees. So minus 90 into minus 90 and minus 90 minus 180 from here, and this will be tan inverse of 1 by 1, that is omega by 1, and this is tan inverse of 2 omega by 1, and this is actually in the numerator, so we have to take positive sign, plus minus plus tan inverse of 4 square, that means 4 omega by 1. So how it will be? Minus 90 minus 90. I am writing denominator part first. Minus tan inverse of omega minus tan inverse of 2 omega plus tan inverse 4 omega. Okay, so this is magnitude, this is phase. G of j omega, h of j omega, and this is nothing but phase, g of j omega, h of j omega. Okay, so let us consider this as equation 3, this as equation 4. Okay, when g of s, h of s locus, actually what we know is if it is actually intersecting the real axis. Okay, let me draw with the plane. So if you have this point, if you remember the polar plot, when the plot is intersecting the real axis, it will be starting in the imaginary axis, it will be intersecting, and this intersection point is the omega at this point is called phase crossover frequency, right? So if you remember polar plot, whatever it is, if you are considering this also, the intersection point, wherever the intersection point is there, that intersection point here, this will be phase crossover frequency. So this is actually calculated for g of s, g of j omega, h of j omega plane, not for s plane. Polar plot we are drawing for g of s and h of s plane. Okay, so at this particular, if it is intersecting the real axis, and at that point, intersection point, what will be the angle? It will be 180 degrees. Therefore, what we can do is at omega is equal to omega pc, that means this intersection point, what is the angle? Phase of g of j omega, h of j omega will be minus 180 degrees. Okay, so just equate this whole fourth equation to minus 180. Okay, once you equate that, I am writing the final expression. Okay, just equate this the normal here. Actually, if you see equation 4, we have minus 180 and minus 180. If you are equating, this will get cancelled out and leftover thing will be there. That's it. And that also, how can we write? We can write a positive sign on one side and negative sign on the other side. Poles and zeros will be separated in terms of phase. Okay, tan inverse of 4 omega pc equal to tan inverse of omega pc plus tan inverse of 2 omega pc. So take tan on both the sides. If you take tan, multiply tan on both sides, how it becomes? Tan of tan inverse of 4 omega pc is equal to tan of this whole thing. Okay, this whole thing I'll take it as some x. Substitute here. Okay, so if you observe this one, this particular function, this will be a, this will be b. Okay, this will be b, then tan of a plus b will be there. Okay, instead of x, I'll make a plus b. Tan of a plus b. From the trigonometry, what we have is tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Okay, so this is a trigonometry function. So from here, if you substitute this function, a will be tan inverse of omega pc, b will be tan inverse of 2 omega pc. Okay, just and tan into tan inverse will get cancelled out, right? Tan into tan inverse will get cancelled out. Then what is left over is omega 4 omega pc is just substitute this formula. Tan into tan inverse omega pc plus tan into tan inverse 2 omega pc divided by 1 minus tan into tan inverse omega pc into tan into tan inverse 2 omega pc. Okay, so here if you observe, all the tan into tan inverse will get cancelled out, and the final expression will be 4 into omega pc will be omega pc plus 2 omega pc divided by 1 minus here omega pc and 2 omega pc is there, so this will be multiplied, so 2 omega pc square. Okay, so we'll just solve for omega pc. Send this one that side and omega pc down so that you can cancel out omega. 1 minus 2 omega pc square will be 3 omega pc divided by 4 omega pc. So omega pc and omega pc will be cancelled out. Okay, so 3 by 4 is equal to 1 minus 2 omega pc, and 3 by 4 you can take 1 this side, and minus 2 omega pc square is equal to 3 by 4 minus 1, and omega pc is equal to root of 0.25, This is actually minus you have, right? So send minus this side. So this will become minus omega 2.5 divided by minus 2. Okay. So this will be 0.354 radians per second. So now what we need to do is at omega PC, we need to compute magnitude. Okay. Here, whatever the cross section point, if it is starting somewhere here, this cross section point, here we need to actually compute magnitude. That magnitude we can compute by substituting omega PC, which is crossing this real axis, the plot crossing the real axis. At this omega PC, we need to compute the distance from the origin. Okay, this distance. That will be computed by substituting this omega PC in magnitude plot. Magnitude plot is equation 3. Okay, in equation 3, g of j omega into h of j omega is equal to root of 1 plus 16 omega square divided by omega square into root of 1 plus omega square into 1 plus 4 omega square. Just substitute omega is equal to omega PC here. So omega is equal to omega PC is equal to 0.354. Just substitute here. Is equal to root of 1 plus 16 into 0.354 square divided by 0.354 square into root of 1 plus 0.354 square into 1 plus 4 into 0.354 square. So if you solve this, you would get 10.64 as the magnitude. So this is how we can compute the magnitude. Now actually we need to find phase, how the plot is varying. For omega tends to 0, so what we need to do is when omega is equal to 0 and omega is equal to infinity, we need to find the phase angle, right? So at omega equal to 0, if you compute phase, what is the phase expression? So this is the phase expression. Just substitute omega equal to 0 and omega equal to infinity. If you substitute omega equal to 0, tan inverse of 0, this will be gone, this will be gone, and this will be gone. All the tan inverse terms will be eliminated, and the rest over will be minus 180. So this means at omega equal to 0, the plot is starting at minus 180. And at omega equal to infinity, it will contribute at omega is equal to infinity, this will be 0. This will be 90, this will contribute 90, this will contribute 90, 2 into omega, that means 2 into 90 and 4 into 90. Therefore here this will give plus 180, this will give minus 180, and plus 180 minus 180 will get cancelled out. This will contribute 90 and 90. Therefore 90, 2 into 90, that is 180. Therefore we'll write it down. For omega equal to 0, phase, I'll take g of j omega as p. G of j omega tends to infinity, and the phase will be minus 180 degrees. Similarly, for omega is equal to omega tends to infinity, phase p tends to 0, and phase p will be minus 270. Okay, just substitute omega equal to 0 and infinity in the phase expression, equation 4. So from these parameters, we can just draw the S plane and G of S, H of S plane also mapping. So for C1 is starting from 0 plus here to here, omega equal to infinity, omega equal to 0. Okay, j omega and psi. So for this one, if you map, how it will become, it will start at minus 180. It is starting at minus 180 phase angle. Okay, and in at minus 180 it is actually contributing infinity, gain will be infinity. Just substitute the gain if you can calculate by substituting in the equation 3, it will be infinity. So there is a small mistake I did it here. This is not phase, this is gain. Sorry for the mistake, I just carefully observe. This is actually gain, magnitude tends to infinity and phase tends to minus 180, and here magnitude tends to 0 and phase tends to minus 270. Therefore, so magnitude is infinity at minus 180 degrees. Okay, JV and U. Here infinity part, infinity you can take here because this is 180 minus 180. You can take here and intersect a real axis at 10.64, at 10.64. So this intersection point, this will be 10.64, and it will intersect here and it will go to minus 270. Then omega is equal to infinity. It is making 0, magnitude 0. So this is how the plot looks for C1. This is for C1. Okay, now we'll see how to draw C2. If you remember yesterday's class, C2 is as same as yesterday's class. Okay, we'll just revise it once again. So mapping of C2, case 2, mapping of C2. So in S plane, if you check the S plane, so just take blue ink. So C2 is nothing but the plot starts at infinity and ends at minus infinity. Omega is equal to infinity and omega is equal to minus infinity. This is nothing but C2. So at infinity, what is the phase angle? I mean, angle it is making is 90 degrees, right? Here 90 degrees. This is minus 90 degrees. Therefore, how can we write the mapping of C2 from S plane to GH plane is by obtaining S term. S should be equated to, so this is this tends to, R tends to infinity, R tends to infinity. For this, the expression is given as S is equal to limit S tends to, limit R tends to infinity, R into e power j theta. Okay, so for any value of S in the right half of S plane, you can consider any value at any point here. If you take any point, this function will give the solution, right? So since it is going till infinity, we are considering R tends to infinity and angle theta tends to 90 to minus 90. Why? Because it is starting at minus infinity where it is contributing 90 degrees and it is going to minus 90, it is contributing minus 90. Tending to minus infinity, it is contributing minus 90. Okay, this is the function. Now, in the given g of s, h of s, equation 1, g of s, h of s is equal to 1 plus 4s divided by s square into 1 plus s into 1 plus 2s. So And one more point I want to tell you here is uh, as s tends to as r tends to infinity, r tends to infinity, s gives the function of r into e power j theta. In the transfer function, if you have 1 plus s tau, where the s tends to r j theta and r is infinity, and this will be infinity, infinity plus 1 will be infinity. So we can write this as approximately s tau. So from here we can eliminate 1 and 1 in the denominator. So how it become is 4s divided by 4s divided by s square into s into s. SS will get cancelled out and 4 by s cube. Apply the function. This function, if you substitute this function, how it will become square 2s and yeah, tends to infinity. And yeah, here actually I forgot to consider 2 here. 2s, this is 2s. Therefore, we'll get 2, and this will be substituted at limit r tends to infinity, r into e power j theta, and how it will become 2 by s cube, right? So just substitute directly 2 by limit, in s place you can substitute this, r tends to infinity, r into e power j theta cube. Okay, so if r tends to infinity, r is in the denominator, and if you take it to numerator, if anything by denominator will be 0, right? And take this function e power j theta, a power n power n, a power mn, you can take that way. Okay, e power a power b, e power ab. Okay, so how it will become is equal to 0 into e power minus, because this is actually going to numerator, j 3 theta. Okay, so this is how the function will come. And what we need to check here is with the angles. For 90, its initial point is 90 and final point is minus 90. So initial theta and final theta should be substituted here. Theta tends to 90 to minus 90, 90 to minus 90. So when theta is equal to 90, if you substitute theta equal to 90, 3 pi by 2, right? Theta equal to 90 means 3 into 90, 270, minus 270. Okay, when theta is equal to 90, g of s into h of s is equal to 0 into e power minus j into 270. Similarly, when theta is equal to minus 90, you get minus g of s h of s will be 0 into e power, if you substitute 90 it's same, and negative negative will get cancelled out, and j into 270. This is how the function will become. And for this, if you plot polar plot and represent in GH plane, let us consider this. Okay, j omega tends to infinity. This is minus 90, 90. Omega is equal to infinity. Omega is equal to minus infinity. R tends to infinity. R tends to infinity and going this direction. Okay, so where it is actually starting, it is contributing e power with the radius of 0. That means actually almost 0 it is. But since we have to represent this angle, I will be taking a little bit, I mean I'll show it, but actually you can take radius as 0. Radius indeed is 0, radius is 0, but to represent it in the plot, I will just consider it. Okay, where it is starting at minus 270. Minus 270 means 0, minus 90, minus 180 and minus 270, JB axis, and this will be U. So it will start somewhere here, it will go till 0, means it is varying from 90 to 0. When it is varying from 90 to 0, this is also varying from initial point will be this and final point will be this. So minus 270 to 270 it is varying. Minus 270 to 0 till here, and from this one, okay, minus 270 to 0 to 270. So final point will be that. So it will go from 0 and end up at 270. If you go in anti-clockwise, there is 0, 90, plus 180 plus 270. Okay, so how it is going? This direction. Sorry, direction. This direction. Where radius is 0. This R is 0. Okay, it will make some angle, but it is actually at the origin. It will almost be 0. And this is how the plot looks for case C2. Now we will do mapping for case C3. Mapping for case C3, if you remember, case C3 is, okay, I'll show it anyway. Mapping for section C3. So section C3 in S-plane, it is actually varying from here to here. That is minus infinity to 0 minus. This is just a reciprocal of the first case, right? First case what we are taking is mirror image, right? It is actually, first case will be 0 to infinity. It is contributing here. And this case will be minus infinity to 0. Just the mirror case, mirror image of this. So similarly, we can take this also as a mirror image mapping. Once you map whatever you got it for the first case, you can take the mirror image of it. So it will start minus infinity, right? Minus infinity, and it will go this way and it will end up at 0. This is at omega is equal to minus infinity, and this will be omega is equal to 0 minus. So this point is same point, 10.64 minus 10.64. Okay, this is the direction. This is the direction. Okay, next thing is case C4. Mapping of section C4. C4 is origin point from here, j omega, from here, that is 0 minus to 0 plus. Omega is equal to 0 minus to omega is equal to 0 plus. Here radius if you see, radius will be 0. So this is the same function which we used for case 2, but here the radius tends to 0. Therefore, how is the function will become function that is limit s equal to limit r tends to 0, here 0, e power minus j theta, e power j theta, r into e power j theta. R tends to 0 because in S-plane r is tending to 0. So just substitute this in given transfer function. And one more point here I want to tell you is, if at all you have a s tau plus 1, since this s is tending to 0 in magnitude, this is tending to 0 in magnitude, so leftover will be 1. This will be 0 and leftover will be 1. Therefore whole thing will be 1. Whole thing will be 1. And so given transfer function is g of s into h of s. It is equal to 1 plus 4s by s square into 1 plus s into 1 plus 2s. So just substitute this, how the transfer function become s tau plus 1. So it will become 1. Here also it will become 1. Here also it will become 1. Therefore 1 by s square into 1 into 1, that is equal to 1 by s square. So for this you have to apply limit r tends to 0 r into e power j theta, r tending to 0. Okay, uh, therefore g of s into h of s is equal to 1 by limit r tends to 0 r into e power j theta square, because this is s square. So r tending to 0, if you substitute 0 in the denominator, whole denominator will be 0. 1 by 0 is infinity. So take out this e power j theta, a power n power n. So mn e power j theta into 2 in the numerator, that will be become minus. Since it is positive in the denominator, it will become minus in the numerator. So r tending to 0, that is 0 into e power minus 2j theta. So this is the final expression. Now we need to apply the limits. So limits is tending to theta. If you see here in S plane, theta is tending from minus 90 to 90, because it is going from here to here. Minimum is 90, minimum is minus 90 and maximum is 90. So just substitute the two cases. When theta is equal to minus 90, g of s into h of s is equal to infinity into e power minus into minus plus. So e power 2 into 90, that is 180, right? J into 180. Similarly, when theta is equal to 90, g of s h of s will be infinity into e power minus j into 180. Okay, so if you represent this one in GH plane, mapping will do j omega, this is jb u. Okay, so here to here, this radius is r tends to 0, 0 minus to 0 plus. So at 0 minus, what is it is contributing is infinity. Infinity is somewhere here, we don't know where exactly infinity is. So infinity, and at infinity initial point is at 180 degrees. So 0, 90, 180. So initial point is somewhere here. It is going infinity and tending towards minus 180. So it will actually encircles, making infinity radius, it will end up at minus 180. Okay, 0, minus 90, minus 180. So this is how the plot looks for case 4. Now we need to club all the four cases. Okay, so by combining all the sections, C1, C2, C3 and C4. Okay, so we'll plot this from first section to last section. Observe carefully. In the first section, if you observe the first section, I'll just show the first section and I'll write. Okay, in the first section, this is what the plot actually looks. It is starting at minus 180. It is going to 0 at 270 degrees. Okay, so this is the first section, polar plot for first section. Second section, it is going to 0. From 0 it is traveling this way and ending up at minus 90. Okay, and third section, at at 180. Second section is ending at 180, right? See, second section is starting here and ending at minus 1 or 180 or minus 180. Actually 180, it is 180, and it is actually starting at 180 and encircling origin and ending at minus 180. So this is how the plot actually looks. Okay, so first point is it is starting at minus 180. I'll write it down with the points. This is U, this is JV. I'll write the angles 0, 90, 180, 270 in the anti-clockwise direction, and 0, minus 90, minus 180, okay, and minus 270 in the clockwise direction. Okay, first where it started is at minus 180. So here it started, it intersected at this point. This point is 10.64, okay, 10.64, and it tends towards origin, at origin, and at origin it encircled. Okay, since I want to show the case 2 also properly, I will take origin point little far from the origin. Actually it is origin, but to show it I am taking little far. Okay, consider this as origin itself, because that radius here is 0 only. Okay, it is starting here. This is still case 1. This is for case 1. Okay, and here it is starting, it is encircling till here and again going and ending up at this point. Okay, this is also 0. Actually this radius is almost 0. This is radius is 0, and from here it is going, this is case 3, this is going to this point intersecting at 10.64 again and going to infinity, and this is case 3, this is case 2, case 2 is this one, C2, and going this direction, and this direction, okay, this direction, and case 4 from 180 it is encircling and ending at minus 180. Okay, so this is how the plot actually ends up. C2, this is C3, case 3, and this is case 4. Okay, here the radius will be, radius is infinity, their radius is 0. So this is GH plane. It's nothing but the Nyquist plot. Now what we need to do is estimate the system stability. So in yesterday's class, if you remember, what I was telling you is how to estimate the system stability in a junk way. If you select minus 1 plus j1 point, see this is 10.64 in the real axis, minus 1 plus j0, minus 1 plus j0 will be somewhere here. If you are considering minus 1 plus j0, it will be somewhere here. Okay, if you are taking it here, if you are going in the path from the initial state, initially it is starting at minus 180 going towards the origin. So if it is if you are going towards the origin, minus 1 plus j0 is coming on the right side. So you remember, if it is on the right side, system is unstable. If you are traveling in a path from the starting to ending point, and in the path if you observe minus 1 plus j0, minus 1 plus j0, this is called a critical point. This is called a critical point. At this point, if you are observing on your right side, then system is unstable. System is unstable.